Hello, 7th grade. This is Miss White. Today we're doing lesson 4%, increase and decrease. So we're going to start with the opening exercise. Cassandra likes jewelry. She has 5 rings in her jewelry box. So in the box below, we're going to sketch Cassandra's 5 rings. So we have 1 ring here. If you want to put like a little diamond on top, I guess that's cool. 2, 3, 4, and 5. Maybe put some designs on it, whatever floats your boat. Or maybe the last one just doesn't even have a design on it. Alright, so we have sketched her 5 rings. And now B says draw a double number line diagram relating the number of rings as a percent of the whole set of rings. So let's go ahead and draw our double number line. I know my lines aren't too straight, but oh well. And now we're going to label. So first, the top number line is going to represent our percent, and the bottom number line is going to represent our rings. So here we're going to have for 1 ring, 2 ring, 3 ring, 4 ring, and our 5th ring. And we know that our 5th ring is going to be out of 100. And then also, when we have no rings, which we're going to use a 0, that means we have 0% of rings. So to figure out the percent of each ring, we're going to take 100 and divide it by 5. So when we take 100 and divide it by 5, we get 20%. So that means each ring is going to equal 20%. When we have 1 ring, we have 20%. When we have 2 rings, we have 40%. 3 rings, 60%, 4 rings, 80%, and then our 5th ring is at 100%. So what percent is represented by the whole collection of the rings? So what percent of the collection does each ring represent? Well, each 5 of the rings equal 100%, and then the part, which is each ring, equals 20%. All right, now let's look at example 1, finding a percent increase. Cassandra's aunt said she will buy Cassandra another ring for her birthday. If Cassandra gets the ring for her birthday, what will be the percent increase in her ring collection? So we're going to use the famous formula that we've been using in class, which is quantity equals percent times whole. Okay. So our quantity is going to be that ring that Cassandra aunt buy her, which is 1 ring. Okay. Then our whole is the amount of rings she already has, which is 5. So when we write this out, we want to have 1 as the quantity and 5 as the whole. Now we will be looking for the percent because it says what will be the percent. So to represent percent, we're going to use P. Now we need to look at the formula here and try to get P by itself to know our percent. To do that, we can divide by 5. And here is why. P and 5 is a multiplication problem. What's the opposite of multiplication? Division. So we're going to divide 5 by 5 to get 1P. And now I have 1 divided by 5, which we know is 1/5. So now we need to know, okay, what is the percent of 1/5? Well, what does percent mean? Percent means out of 100. So we need 100 to be our whole. So to get from 5 to 100, we have 5 times 20. So now we're also going to do that to our numerator, which is 1 times 20. And so now we have 20 over 100. So remember, when we talk about percent, we want to think about our percent over 100. So now we know that our percent is 20%. All right, now we're going to move on to example 2, which is on page 22. So we're talking about percent decrease. Ken said that he's going to reduce the number of calories that he eats during the day. Ken's trainer asked him to start off small and reduce the number of calories by no more than 7%. Ken estimated and consumed 2,200 calories per day instead of his normal 2,500 calories per day until his next visit with the trainer. Did Ken reduce his calorie intake by no more than 7%? Justify your answer. So again, how we're going to set this up is we're going to use our formula quantity equals percent times whole. Now, we need to know what our quantity is. So our quantity is when Kevin reduced his daily calorie intake by 300 calories. And we know that because he started at 2,500 and he went down to 2,200. So that is going to give us our 300 calorie deficit per day. That is going to be our quantity. Now, the percent. His trainer said that he needed to reduce it by 7%. So now 7% is going to be recognized as 7 over 100 because percent means out of 100. Then our whole. What is our whole going to be? Well, our whole is the amount that he was eating, which is the 2,500 calories per day. So we're going to multiply 7 over 100 by 2,500. Now, because we've been learning how to convert fractions into decimals, we need to convert 7 over 100 into a decimal. 7 over 100 into a decimal is going to be 0.07. And we know this because when we think about our place value here, we have our tenths and our hundredths place. And because our sevenths and our hundredths place, that means when we convert it back to a fraction, that it's going to be 7 over 100, which is given to us in our formula. So now I have 0.07 times 2,500 equals 300. Well, does 0.07 times 2,500 equal 300? Go ahead and calculate this in your calculator to see. All right, and it is not 300. You should actually have gotten 175. And so this is false because 300 does not equal 175. All right, now we're going to move on to example 3, finding a percent increase or decrease. Justin earned 8 badges in Scouts as a Scoutmaster last report. Justin wants to complete 2 more badges so that he will have a total of 10 badges earned before Scouts Master's next report. A, if Justin completes the additional 2 badges, what will be the percent increase in badges? So again, we're going to use our famous formula here, which is quantity equals percent times whole. And we need to figure out first what we are going to be finding. And it says what will be the percent. So the percent is what we're going to be looking for. And now what is going to be our quantity? Well, it says if Justin completes the additional 2 badges, that means that the 2 will be our quantity. Now, by looking at our problem above, we already know that Justin has earned 8 badges in Scouts, so that will be our whole. To set up this formula, I have my quantity, which is 2, equals my percent, which we're looking for, and we can use P to represent percent, times the amount of badges we have, which is, or that Justin has, which is 8. So now I need to get P by itself. I know that this is a multiplication problem, so the opposite of multiplication is division. So I'm going to divide by 8 on both sides to get 1P, which is what we want. Now I have 2 divided by 8, and if we want to simplify this, we can simplify it by 2, and that's going to give us 1/4. Now we need to get 1/4 to be a percent. So I know that 4 can go into 100 25 times. So I'm going to take my 1 times 25 now, which I know is 25. So now I have 25 over 100, and I know that percent means out of 100, So my percent is going to be 25%. So now we know there will be a 25% increase in the number of badges. All right, B, it says express the 10 badges as a percent of 8 badges. So we're still going to use our same formula. This time our quantity is going to be 10 and the amount of badges is going to be our whole. So when we set this up, we're going to have 10 equals percent, as that's what we're trying to find, times our whole. To get percent by itself, or the P, we're going to divide by 8. And so now I have 1P. And 10 divided by 8, when we simplify this as a fraction by 2, we're going to get 5/4. Now again, we still want to convert this to percent, which means out of 100. So again, we can get to 4 to 100 by multiplying by 25. 5 times 25 is going to give us 125, and so now we know our percent is 125. All right, and that concludes our video for today. See you in class.